Architeuthis.
Hi, I'm Guy Cope of Architeuthis LLC, and welcome to Machine Learning Mondays, the series where I try to knock the edges off buzzwords and make machine learning accessible to all y'all. Today's topic I'm going to start off today's video with a quick notice that these two types of machine learning are less commonly used in the financial crime space. Semi-supervised learning is more likely to be encountered, but I've yet to encounter reinforcement learning in fraud, AML, or any of the other areas typically put in, such as KYC or sanctions. Having said that, these are still important techniques and could at any point in time be adopted. Semi-supervised learning, for instance, has become something of a growing field in transaction monitoring and customer analysis. So let's start there. Let's start with semi-supervised modeling. As you may have guessed from the name, semi-supervised modeling is sort of a middle ground between traditional supervised modeling and unsupervised learning. To refresh, supervised learning requires training data, or labels, and decisions fed into it by humans that teach the model how to work. Unsupervised learning, on the other hand, looks at patterns and similarities to create networks and clusters in the data. Semi-supervised modeling uses both techniques at the same time. One of the biggest issues in machine learning is that it uses a very, very, very large amount of data. And creating labels for all of that data can be troublesome and takes a lot of time. We could be talking about months or years depending on the type of model you're putting in place. On the other hand, unsupervised learning doesn't have that same level of accuracy and precision as supervised learning. So while it moves faster and doesn't require as much human input, it still isn't optimal for every use case. So what happens if you have a lot of data, but not a lot of labels for training, and not enough time or resources to create the labels in a timely manner? You used semi-supervised learning, of course. In semi-supervised modeling, you train the model with a small amount of data. Instead of hundreds of thousands of labels, or millions even, you might use hundreds or thousands of labels. You then validate the initial results to get to an acceptable level. This level is not going to be as high as a traditional supervised model, but it's going to be a point where you feel comfortable with using the model. Initially, it's going to be lower than the full-fledged model, but still acceptable, and then you let the model make predictions on the unlabeled data, making connections and finding similarities without human training. Then, after deployment, the model continues to receive label data from the outputs, like a traditional supervised model, improving its accuracy over time. And this has a few benefits. The most obvious benefit is time. By requiring less training, the semi-supervised model can deploy faster. Another is accuracy. By ingesting some labels, it can better mimic the desired behavior, and it can continue to grow over time. Semi-supervised models also detect emergent or unknown behavior more quickly than traditional supervised models. Since not all of the data is labeled, it can find new connections where a traditional supervised model can't. The downside to all of this is that it's still less accurate for known behaviors. This makes semi-supervised models better for catching new behaviors or predicting partially known types of behaviors. So the same thing that makes it less accurate is what makes it more likely to catch emergent behaviors. So the recommendation on semi-supervised models would be to use them where you're not as sure of the outcome. If you have specific typologies or MOs, like certain types of fraud or suspicious activity you're looking for, a traditional supervised model would be better. But if you have a large amount of information and a large amount of customers, and you are trying to anticipate what new vectors are occurring, semi-supervised models can really help you in that case. Let's move on to reinforcement learning. Reinforcement learning is very similar to the psychological concept of reinforcement. It's about maximizing the rewards to make the machine perform in an optimal manner, whatever that manner may be. The big difference between reinforcement learning and supervised learning is that supervised learning has a specific output. If you remember, you have product features that humans come up with, and the supervised model is looking into those product features and trying to optimize to find those desired outcomes. The human in the loop wants that specific answer, and it's going to train it using that label data to find that specific answer. But in reinforcement learning, the specific answer isn't sought, but the model is given a reward for answers that are desired by the human. This gives the model more flexibility to find new behaviors, but it may also find completely unknown or even irrelevant information. And this makes reinforcement learning very unpredictable. It's not unusable for transaction monitoring or compliance, but it's much harder to explain and validate, and that makes it harder to defend to examiners, and it even can make it more difficult to tune to specific KPIs or key performance indicators desired by senior management. So let's take a look at a possible use case. Let's say we have a reinforcement learning model ingesting our customer data. The model has many possible outputs and will surface a customer based on that output. The human then rewards the model, marking it a true positive, or punishes the model by marking it a false positive. The model will then produce outputs that maximize the reward. At no point does the human put a goal in front of the model, like a product feature looking at fraud occurrences based on money spent at specific stores. Instead, it will come up with whatever output that it can find that matches the previous rewards. As a result, reinforcement learning maximizes general performance over time, but never really hits a maximum performance for a specific goal, finding that specific kind of fraud, for instance. That's why you find reinforcement learning more often in things like video games, where you have artificially intelligent enemies who are reacting to what the player is doing, or in robots, where you have a robot that wants to perform a specific task, but you need it to do that across many different varieties of, say, cars to put together. And that's because it's more of a general. I want to do these things, and it's more of them, and I don't care if you get any specific one. So if you're looking at a specific type of fraud that you want to find, reinforcement learning is not going to work all that well. But let's say you were trying to find lots of different types of fraud, reinforcement learning might actually work in that use case. What I go back to is, if you ever watch the Watson versus Jeopardy players, you'll find that Watson is really much faster and more comprehensive than the Jeopardy players and wins the match easily. But it also comes with totally irrelevant results at times that a human would never answer, because a human would know that there's nothing to do with the actual trivia that you're trying to give. So reinforcement learning, because of that, is not optimal for these things, but it's not useless either. For today's topic. This one's a shorter one because, again, these are less common techniques, and therefore it's not quite as imperative that you have expertise in these areas. But I will say that semi-supervised learning is growing much, much faster than some of the other types because it has that ability to detect emergent behavior. And this is especially true for systems that share customer data on a data lake, where you might have many different companies putting their data in one place so that you can make the models perform more effectively across those companies. Just because your company is based on the West Coast and the other one's based on the East Coast, and you're in two different industries, doesn't mean that data can't be useful. However, if you don't have a ton of people to mine data, if you don't have a ton of data analysts to look at that data, then a semi-supervised model can really make it move a lot faster and require less human resources on the back end. Now, that will mean that the end results in many cases will require more human resources, because you are going to get a few more false positives than you would with more traditional machine learning techniques. In reinforcement learning, I think there's still a little bit to go before that's really widely adopted. It's more unpredictable, and again, normally in fraud, you're looking for a bad guy. You're not looking for a general customer behavior, and that does make it less optimal. So I hope today's video gave you a better understanding of these somewhat more advanced machine learning techniques. And as always, I hope today's session was helpful to you. If you enjoyed the video, please like, subscribe, and leave a comment below. And if you have machine learning questions, and I expect you do, remember, Architeuthis has you covered.
Thank you for watching. Please like, subscribe, and leave a comment.